And action.
Welcome everybody to Dallas Programmable Robotics Group for October 1st, 2024. Tonight we'll do our normal roundtable discussions and presentations. And if you have any questions or you need help or stump the club, let us know. Give us a holler and we'll try to answer the best we can. I want to remind everybody that these meetings are recorded, both video and audio. So if you don't want to be seen or heard, turn off your camera and mute your microphone. With that, we do have an upcoming event, Robocolumbus 2024. Dates are getting close for the US group. They are going to be on November
23rd.
November 23rd. And for our Canadian friends, it's going to be on October 26th. So it's a split event. So we'll probably be recording on the 26th of October, a little less than a month away now. And we'll have it probably presented on their Saturday meeting in either online, I'm guessing, not necessarily at the Dallas Makerspace. And then the following month, it'll be our Dallas group, and they'll be hosting it on site, I believe, still at Steve's property, is it? And you can reach out to the Dallas members for location if you're going to be attending in person. So two separate events for the Canadians and Americans, and Robocolumbus is an outdoor event. Autonomous rovers, going too far.
Oh, I'm sorry.
That's all right.
Yeah,
And for you guys that don't know, Robocolumbus is an outdoor autonomous rover contest with layered objectives. Contest layering provides opportunities for roboticists of different skill levels to compete. All contestants that score at least 1 point, see the rules that are highlighted, will receive a Robocolumbus 2024 coffee mug. The special mugs are awarded to contestants who achieve a perfect score, 9 points. 9 points. Similar mugs will be awarded to achieve one of the advanced challenges. See the rules. Additional prizes and awards to the contest. The contestants that place in the top positions must be a mug winner, and the contestants are open to the public. Anyone can compete, and all are welcome to watch. So it's a fun event. I've watched it online in the past years. It's been excellent. I'm going to try to participate again this year in Ontario, Canada, with my Southern Ontario friends. And hopefully we can entertain you guys. With that said, I guess we're ready to kick off the meeting. And we'll start the presentation with John.
Okay, and I will click a window once I figure out which window I want. Okay, there should be more. Oh, no, we'll go with, there's the line mapper, yep. So first thing I found was this for the person who wants just a one-eye robot, seemingly, or something, but might like that for the eye movement. Seemingly super simple, they train. So there's that. And then there was an article I saw, which I thought might be of interest. So let me undo what I need to do, which is undo window. Where's okay, and then present other window. So there was this article I found, which it's going to have a little bit of advertisement in it, but seemingly there's a robot team to deliver in Dallas. So they had the picture of that. And it's a combination thing. So seemingly it's a spin-off of Uber and Ring. And it'll deliver within 6 miles from the place. So it looks like we're going to have more robots delivering. And right now, it seemingly operates out of Los Angeles.
That's a long way from Dallas.
Well, they actually had some deliveries same at Walmart. I forget which town around here, but there's one where they had a video where it was literally dropping the package from the. But this one seemingly is combining a robot and a drone. So it's sort of a both type thing, which is what really caught my eye. The fact that was a combination. And seemingly, if you ever go over to the University of Texas at Dallas, they deliver there. I have not.
Okay, so the drone takes it to a location, and then the location has a robot which picks it up and then takes
Yeah,
the last mile. Yeah.
see, that's where the picture where they're sort of showing where I guess it drops into the chute, and then from there it opens its lid and drops it into the actual robot. So it's a combination. Where before they were just having the drone, lower the package down into your yard. Now they're going to combine the two. I don't know. I guess they did it mainly for more range or something. Because in the article it says something about 6 mile radius.
Well,
I think it's more likely about not having airborne drones come up down over neighborhoods where people have privacy concerns.
yeah, and not just that. I think it's probably a lot easier to have the drone come to a specific safe location somewhere, and then have the robot do the final mile. Yeah.
But surely they could make it a little bit more complicated. Just give them time.
Well, maybe the last 50 yards they'll hand it off to a humanoid robot.
There you go.
Up to the door. I like the picture of all the things on the pedestal there.
They'll hand it off to an out-of-work dock worker.
Yeah, right. But he won't, because he can't be automated, so he'll have to do it the hard way.
The hard way, right?
And then his last step for the out-of-work dock worker should be to come and throw the switch to toggle the LED.
Yeah.
He'll want $75 an hour to do that work.
You say it like it's a bad thing.
Yeah. Anyway.
It's a good thing.
So that was what caught my eye, as I said, the fact that, it had that 2-part to it.
Well, thanks, John. That was interesting.
Okay.
Next up, we have Carl.
All right. So this is remarkably, I have something robot related to share. It's not personal, but it's kind of a question. So who's up for a field trip for an on-site repair? They just don't build robots quite the way they used to. And it looks like there's an opportunity coming up for some on-site repair work. Looks pretty easy. You just have to change the wheel.
Yeah.
So
It's holes in its wheels. Oh no.
I guess 12 years and 20 miles. What is it? How many miles per year is that? But apparently it's kind of an interesting thing. I posted 2 links in the chat. And apparently solid aluminum wheels on this first one. They've known about it for a long time, and they actually consider route planning to be gentle to the bald spots on the tire. So
It's like it's crushed right through.
oh yeah. It's
Yeah.
right through, so you can see the innards, and there's some neat pictures in here, and I'm sure there's some others around too. But
So why is it wearing down? Is it because it hit a rock or what?
yeah, sharp
Because
object,
it's,
right? I mean, the thing's heavy enough.
Well, that's what I'm thinking, because it looks like, like it went over this rock and it made an impression on the wheel.
Well, the wheel itself is made out of aluminum. It's not, like got a rubber tread on it or anything. It's actually aluminum wheel.
Right. If you scroll up to that one picture where they have the hole in the wheel type thing, you can see the ribs.
The jagged aluminum.
Right.
Yeah, I'm sure it's fairly thin aluminum just for weight.
Yeah.
And then it looks like they have some type of tar, rubber, or something.
No tar rubber. Just straight aluminum.
They just imagined that it would distribute the force pretty evenly, and
okay,
and didn't account on sharp enough rocks and spots.
To snap it.
And then they showed that they knew this early enough in advance that they changed the design for Perseverance to be. And so far, I don't know how far Perseverance has gone, but the article mentions that it hasn't experienced any of that problem yet.
Did the article say anything if there's any corrosion, or is it just wear from friction?
I didn't read that much, so I didn't notice it if it's in there.
Okay.
I thought it, Ted, I thought they said the problem was they went over some, banged in some rocks as they went over them. So think of it as like going over a funky curb, and they got over it, but the wheel suffered.
Yeah, it's just from the friction and rubbing and scratching, I suppose.
Yeah. Well, the banging.
Yeah, banging. Sure.
So I thought that was pretty cool. I mean, just imagine, guys. These guys. I mean, it's on another planet for the last 12 years. It's driven 20 miles and still getting it to go. So it's pretty cool if you think about it.
Yeah.
Not like it's just floating through space for 50 years, but that's another remarkable challenge.
I'm just thinking I should send a proposal to NASA for a wheel changing robot.
And it's funny you mentioned that, because that's a great segue to my next thing. So it's kind of related. It's not really robot-y, but it is related to changing wheels and tires. It's a public safety announcement. And I don't know about you, but I really think you should wear shoes for certain jobs. And I think changing tires is one of them. So
oh God, this is going to be gross.
Oh no.
so
No.
if you want to change some tires, these guys show that you don't really have to stop if you want to go there. So I'm not going to roll a video because it's easier to enjoy on your own. But sure enough, it's
Wait, you're saying they're still driving?
Oh yeah, this is rolling down the road.
No jack,
Look how you get it into the tire changing position, right? Don't mind the other people on the road. I guess that's why there's no dividers in Saudi Arabia, if I read this right. But there we go. Okay, now we can get started. But you gotta have somebody outside to open the door, I guess. So
Now I want to know how they refuel the car.
What gets me though is, just think of the safety. They're not wearing shoes. They're all barefoot. That's just not safe. They should have shoes on.
They're actually doing a pretty good job of balancing.
I think the barefoot might be an advantage in this situation. Oh my God. That's just crazy. How come the one wheel isn't turning?
Should it be turning backwards?
I guess it's a differential, right? So yeah,
but then the one that has no strain on it should be the one moving faster.
Is this a 4-wheel drive vehicle? Yeah.
I know, but how do you stop the left two wheels?
I don't know.
Yeah. Are you suggesting this was photoshopped?
No, it couldn't be. That's got to be 100%.
Yeah.
Suspicious.
Might be. I
They
would
make
hate
pretty
for
good work of it. I mean,
so-
yeah, here's the spanner. You might need the spanner up front, guys. Okay.
Do
What if
you
the car
during a
has
drop
the
command?
ability to lock each wheel independently or something?
So I'm
Man,
telling
there's
you,
a lot of trust in that driver.
if I have to go to Mars to change Curiosity's wheel, I'm going to wear shoes.
Yeah. Good idea.
Okay, they actually tape. Okay, then what happens? Does
Now
it
what
bend
do you do?
down?
Okay,
Yeah.
all done. Time for a coffee break.
I think they're going to have to change those other two tires that are being rubbed on their sidewalls, which
I think they just realized that they don't have a spare.
Well, the spare's on the back, so I thought they cheated because they really should have pulled the spare off and swapped them. But
Well, they could have rotated.
Yeah.
yeah, they rotate three-way at least.
I won't be impressed until they accomplish an alignment at the same time.
And do an oil change.
I wonder if they cheated. Real close to that tire in the back. Is okay. No, that's that flap.
And then, here's somebody in the passing lane, right? Never mind the tire change that's going on.
passing on the right. Yeah.
Yeah. 1, 2. It looks like.
So is it a cultural thing that you should just keep moving in their society, or
You definitely have to stand up and cheer on the moving vehicle. So in your bare feet. Don't drop the lug nut though. It might take a while to go back and get it. Hooray! Okay.
Yeah.
how they get it back on 4 wheels and run over a couple of them?
No. Did I see it get back down? No.
How many views have they got? A million?
1.6 million.
Jeez.
Jesus. 10 years ago, huh?
Been around a while.
So there you go.
And that was a
Yes.
cooking channel?
I don't know what it was. It showed up and I couldn't resist it. And I didn't realize how well it was a segue from Mars Curiosity until we got on this call here. So I may not have much to contribute, but I wanted to try something. There you go. I'm done. You should send me off now to do something productive.
There you go. Well, thanks for the update, Carl. Are we done? The update, the presentation was good. Funny. After that, I have a little bit of an update on my robot. I've been fighting for the last few days trying to get my maixsense A010 sensors working. What seemed to be working okay as I was reassembling my old outdoor bot, because I don't have time to get the big outdoor bot ready. I started plugging in some USB ports on my Raspberry Pi, and my sensors started to freeze. So like the screen wouldn't be changing anymore, the little LCD screen, everything was just locked up, and it was sporadically. Turns out Raspberry Pi 4 USB ports can only supply about 100 or 150 milliamps. And it was starving for current. So they were glitching out. I did have them plugged into USB hub, but I didn't have it powered separately. So I made the switch. I built a cable and connected it up, powered it separately on the hub, and lo and behold, they are working steadily now. No issues. So that's good. Puts that problem to bed, and I can carry on working. So I have been assembling the wiring mess just testing things out. It's sort of coming along, and hopefully we will be ready to roll shortly. And we're running out of time. It's for us, it's 25 days away. And I hope Tom is doing at least as well as I am, or better. I am determined to get at least from one GPS point to another during the contest. I don't know if I'll be able to, in the vicinity. I don't know how well it is going to work, but most of my routines have been tested independently, and it looks like they're okay. So I'll be trying to get everything working this week and getting it rolling and going from point A to point B.
Well, Mike, Pat, you got, up there, you got kind of, I think, a little bit of advantage because you guys are all, this is your first year doing it. You know what I'm saying? And so the rules say that, the first 3 places, will be given out, and but you have to have a point. So that means you get a mug you have to have a mug, be a mug winner. Well, to get a mug winner, you only have to get within 10 yards of 10. You have to pass by the cone by 10. I think it's 10 yards.
I thought it was 10 feet.
10 feet. I'm sorry. I wasn't sure. Yeah.
Well, they're in Canada. It should be 10 meters, right?
Well,
3 meters.
It should be 10 kilometers.
There you go.
well, what I'm trying to say is, you don't, even if it just drives by and doesn't stop, as long as it went by 10 feet, you get a point. So, go for that mug, and who knows, if you get a mug and you're the only one who gets a mug, you win first prize. Now, now if John's still competing and he comes there and gets 9 points, well, maybe you won't get first place, but you might get second or third. There's 3 of you, right? Right, Tom? 3?
Well, there's me and Pat. John has already said he's not coming, but he could always change his mind.
Yeah, you can always change his mind.
And we will have some audience participation. Norm from near Ottawa plans to come just to watch, and he may bring some people with him.
All right, so I'm saying, do the best you can.
We will. I'm scrambling, trying to get a robot up and rolling and moving to do it, and I'm looking forward to it. Actually, I think I'm close.
I was discussing my progress on Sunday with the Vancouver and Ottawa guys, and they said, based on what my progress rate, they said, work really, really hard to keep it from bumping into things. That would be a good progress rate.
Hey, Pat, so I have a question. You use GPS, correct?
I'm using GPS, and only to get me in the area.
Okay. Do you convert the degrees to local coordinates like meters or something?
I do convert the coordinates to centimeters, I believe.
Okay.
So it's a big number. There's a lot of centimeters in 300 feet.
Yeah. So I was working on that the other day, and just going on Google and comparing my results, and it seemed like Google was giving me a little longer distance than what I was calculating. I take the latitude and take the cosine of that, and then multiply that by the circumference of the Earth divided by 360, and same thing for just take the the polar circumference divided by 360 for the longitude, I think.
I don't think I went to that depth, because I'm not talking kilometers. You know what I mean? I'm not talking 10 kilometers distance. I'm talking 100 meters. And so a flat representation is close enough, I find.
Yeah. I mean, even when I did that though, my calculation was like 2 or 3% smaller than what Google was saying as far as, you know, just taking the Google measure distance tool. So
3% is 10 feet.
yeah. Well,
Oh, 9 feet.
no. Well, yeah, for, let's see, 300.
And by then I'd be kicked into a camera to try to find it.
That's right.
Yeah. Well, and it was more like 300 feet. 1% would be 3 feet. So yeah, 9 feet.
Yeah. So I'm not going to find it with the GPS.
Yeah.
So,
Well, and GPS accuracy is only a, you know, plus or
It-
minus
it-
a few meters.
let's say 30 feet plus or minus. So as I approach where I think the cone is, I'm in the area. It's
Okay.
time to start looking.
Yeah, maybe I'm just overthinking it, trying to convert the degree coordinates into something flat. Probably I'm just overthinking it.
I was trying to go from averaging my GPS coordinates to something more like a filter. I don't know, Ackermann filter or something. But you know, electrician math is only so good. And you know, 70% of electricians are mathematically illiterate. Almost half of us. So not very good.
So, Ted, last time I was messing with it, there were several routines that were available on the web for, you know, finding the distance that you'd moved.
Okay.
And so what I did was I looked at several of them, and I was able to find one that was very accurate. So I would take just two GPS coordinates in my yard or down my alley actually, and I would have it calculate. I would have Google tell me what the distance between the 2 points was, and then I would also do this calculation, and they were almost dead nuts.
Okay.
So, you know, I don't know if it's because you know, the representation up in Canada, or I mean, well, you're in Colorado.
Colorado, yeah.
Yeah, so it should be the same. I wouldn't imagine it's so I was able to do that. Now, it was very interesting to, you know, one thing that I noticed with the GPS, and this is without any real complex data fusion, is that because your error is, let's say, 9 meters, if you're 100 meters away, that's right, that's 300 yards, 100 meters. Yeah, so 100, you know, when you start off, it doesn't really make much difference because it gets you going in the right direction. But as you get closer, it gets more important because now you're trying to be actually 9 feet from some specific location. But if you look at yourself being 100 yards from the location, it's not that big a deal. Anyway, I think the real one of the things that John did before he dropped out, there's 2 approaches. You convert everything into global coordinates. So you're always talking about meters to the cone based on where you think you are on the GPS with the GPS and your probably your IMU, and as opposed to starting off where you say, okay, I'm at the start line, I'm at 0, 0. Okay, and then taking your GPS and converting it to an XY coordinate into local coordinates. And so there's 2 approaches. One where you can move the coordinates up to the global, try to do it that way, and the other one where you can move it down to the local.
Yeah, so for me, I'm taking a system that was not using GPS, just using IMU, and I'm adding GPS to it as my goal this year. So I already have everything in the local coordinates, and so I'm trying to go that direction. and I kind of assumed it would be a fairly simple calculation, and I think it is, but it's just giving me trouble. So maybe I just need to look it up. Anyway, you probably
that way too, Ted, this year, because with a differential robot, I think it's easier.
Yeah, I think the right solution would probably be to go to the global degree coordinates, but that seems like overkill for something going a few hundred.
Well, again, yeah. If you have it depends, I guess, on whether you have a compass or not.
Yeah.
You know, you have to have something that's telling you what you think, which way you're really going, you know. And there's a couple, I want to say that I know that David Anderson, in at least one occasion, and I'm not saying he does it now, in one occasion, when he set his robot down on the start line, the compass, he let it run for a while on the compass before he started. And then he just took that reading and added that to his IMU reading. And so everything was, he didn't actually use his compass again. And I don't know, he might have reset it when he hit the cone and, you know, started going to the next one. I don't remember what he said, but I know he used his compass only in the very beginning.
Yeah, so you're saying he just used it to get his initial heading, and then he worked off of that.
Right.
Yeah.
Yeah. And you might, you know, I also think that might also give you, like I said, now you start getting into filters, is, you know, it also kind of gives you a belief that you can have against your your GPS sensor too. So if your GPS sensor suddenly says you need to go 40 degrees different, and your IMU and your compass initial says, no, that's not, you know, you didn't really do that, you can probably ignore that GPS point and wait for the next one. So I don't know. That's the axle I'm wrapped around right now. So I'm trying to figure it out myself.
I've been bitten more than once by magnetometers, just suddenly deciding to go 10 degrees because of whatever.
Yeah. I don't know. We'll see.
Yeah. All right, Pat, back to you. I've taken over long enough.
That was it for what I had. Just what I was doing with my GPS readings is basically just trying to get the distance and direction to the next point.
Okay.
And working my odometry that, hey, I'm getting close, correct, and try to carry on further.
Yeah.
Have you ever looked at David Anderson's stuff? That's pretty much what he does. His azimuth is what your heading should be, and meters to go is the distance.
Yeah.
He didn't really use GPS, did he?
Not initially, but he did bring it in later.
Okay.
It is now, well, what happened was he decided he was going to take his JBot, he was going to update it to a Nucleo board, and that kind of blew it out of the water. And so his robot right now isn't working, but when the last was running it, he was using a GPS.
Okay.
But he wasn't using anything fancy. It was just an old Garmin. And I mean, one of those old yellow body Garmins from the 90s.
I have one of the models he has.
Yeah, it's really old.
Does anyone use a ground plane with their GPS antenna?
I did that. I did that a while on one of my robots, and I will say this: I think it helps.
Yeah, supposedly eliminates a lot of the multi-bounce, something like scatter.
Let's see if I might have one over here.
It's probably necessary for a RTK style antenna.
Tom has one of the yellow ones.
Yeah, that's it. An E-Trex.
Yes, it is.
Garmin E-Trex. That's what I had, one of those as well, but I've switched to.
Okay.
And it has a serial interface on it.
Ray, is that about the size you need to?
Yeah, see,
Yeah, it's, I thought they said it was 4 inches, but it seems like it's bigger than that.
I want to say it's 6 inches.
Oh, no, 4 inches.
Let me see what.
So
Anyway, it's like a 1/8 inch thick steel plate
Okay.
with a threaded hole, 1/4 inch threaded hole in it, so you can put it on a tripod.
Yeah.
It doesn't need to be that thick. You know, I
No.
don't know why they make them that thick, but I know how they send them that way. But it's like
Yeah,
it just needs to be a good conductor, and shield you from that ground bounce. So the size, like Doug's, is huge. It's like a 6 or
That's a 6 inch. Yeah.
6 inch.
And that's because I just got, for me, it was easy to get. And
It really depends on the height of your antenna, right? You're
Yeah.
really shielding it from reflections off of the ground.
Is it just shielding it? Does it need to be electrically grounded or anything?
no.
No.
Oh, well,
It doesn't.
Okay.
I
I
think
mean,
I
it's
grounded-
probably better for it, but your robot's probably not going to be grounded to ground, true ground, right?
Yeah, that's true.
I did. Okay, so this is not a GPS. This is an antenna. Okay.
Right.
And it goes down to the GPS. And
Yeah, it's the antenna where you need it.
Right,
It's
so
how tall your antenna is.
yeah, so the metal box that's underneath the little ceramic antenna, I grounded that to the ground plane.
And if you think about it, if you're in a valley, it doesn't matter how big it is. You're
Yeah.
still going to get ground bounce.
Yeah. So anyway, it was a fun project because getting that out of that little plastic case that the antenna came in and getting everything glued on, soldered on and everything. And like I say,
Now, just out of curiosity, have you observed any improvements as a result of adding that shield?
I think I did. I mean, I did it in conjunction with I think it was a 9. Yeah, I think it's an M9, which was the best GPS that I had. It was, I had been using M6s, and I might even used an M8. And this one, I went up to an M9, and it was also a lot more money than I ever paid for a GPS than I had before. Though I'm still not in the RTK range. These guys that do that are really spending the jack. But it was fun, and I do think it helps. I plan to use it again, probably. We'll see, because I can imagine the pressure that Pat and Tom are on, because I got an extra month and I'm feeling like, oh my God, I'll never get this right. So anyway, good luck, guys.
I've also got about a 5-day trip up north before the end of October as well, unless I push it off into November.
Yeah.
So.
Yeah.
So that's it. That's it for me. Next up, I think we had Ray.
okay. Well, I had 3 things to do for the outdoor robot. One was fix some glaring software mistakes. I think I've already done that. And the second was to try to improve my bumper. The last contest, it got the bumper actually, well, it's like hinged in the front of the robot, and there's 2 switches on each of the hinges. Well, 1 switch on each of the hinges. And so I thought if I could make something kind of like this to go around and, kind of like into the interior of the outside of the wheel, because it's got a flat surface where the tread is, that weeds couldn't get in between the bumper as it went forward or backwards, because this is recessed into the wheel, So the wheel, the tread of the wheel would be crushing it or pushing it down. And then, so when the, you know, and it had to have the right amount of travel so that it didn't, you know, prevent the reel from rotating or chatter up and down when the wheel was rotating. So I've 3D printing the second one of these, and I'm going to stick it on the front of the bumper. And like I said, the wheel will kind of fit in here. The center will be back here. And so I am hoping that that is going to keep the Texas thicket out of my bumper. So you're muted, Doug.
Ray, I think I see a fallacy.
Oh,
What does your robot do when it hits something?
it stops, backs up like 50 centimeters.
Yeah.
Turns.
Now look at your bumper. Hold your bumper up.
Yes.
Okay, hold it up. I can't
Hold it
see
up.
it. So we can see it. Now move it backwards. No. Oh, wait a minute. Okay. So where's the wheel fitting now?
The wheel is, the tread part is here, and then the axle is here. So this is like, I don't think I have a loose wheel.
Okay, I thought it was going pointed downwards. If it's
Oh,
you giving
no.
us a top-down view right there?
Hold on a second.
I think it was a bottom-up view.
Yeah, I thought it was a grass hook too, when he was showing it before the
Yeah.
recording started.
Okay, so this is the wheel, and it's got a pretty good recess on the, this face is on the outside. So this was going to go here, kind of around the wheel so that I can't get stuff
I got you. Okay, I thought it was
right
pointed,
here.
and I thought you had a little shovel there.
Oh,
Okay.
no. So this, you know,
Yeah.
the bumper is horizontal and it moves back and forth so that, you know,
Cool.
pretty much if I do get jammed into weeds, I can back out without getting, because stuff was getting stuck around just the end part of the bumper. And then I couldn't, you know, my
Yeah,
wheels would just spin. I
Couldn't
couldn't
get it out.
get out of
Yeah.
it.
You ever think of installing one of those, you know, the big weed whippers with the steel blade?
Whippers. Oh, now what do you mean? Whippers with a steel
He
blade.
said
It whip- it
a weed
whippers,
whacker.
Oh,
big
yeah.
steel-
Cut my way through it. Yeah. Yeah. The other idea that I had, if this doesn't work, I have some, I don't know if you can see it. It's music wire is what it's called.
Yeah.
And I was going to make like whatever, cat whiskers, cockroach antenna, you know, whatever you want to call it. So that, you know, when they catch the grass, they bend back, and then they could also bend forward when I'm pulling out, and hopefully they're flexible enough to, you know, to be able to bend. They seem pretty flexible.
Yeah.
The
But-
problem with that is the grass may end up bending them, and you know, and then you get false positives and stuff.
Oh, yeah.
I've always found those little cat whiskers. Now it could be the way they were set up. They were, the ones I've had were set up between two poles like this. So
Yeah.
if it got hit, it would hit one pole and complete a circuit. Okay.
Oh,
Those
on
are
either side.
very, very, very sensitive.
Yep.
Because that thing out there is kind of woman like that. And
Yeah.
so if you do that, these two prongs between the trip points should be far, you know, give you plenty of room. So, you know,
Yeah. To have
like,
it bend and flex.
yeah, like Ted said, you'll get a lot of false positives.
Yep. Anyway, so hopefully that is going to fix it. The other thing I did is got GPS R2K to work. I made pretty much a base station. Yeah.
Has anybody that's using RTK checked with Steve to see if he's up and running on his station.
That he's what?
Yeah, he's got a station up there. He was on the, what is it? Something to go.
RTK to go.
Yeah, he was on RT to go for a while. I haven't checked him because I don't have RTK, but I was wondering if he's still on up there, or are you guys going to have, like, Paul's going to have one, you're going to, you know, Kareem would have one, and Ray would have one, and Steve, I mean, you're all going to have all these different stations, or how you guys?
I was able to use the RTK to go station that's been in Richardson for years.
Yeah.
From at his place, and it worked fine.
Okay.
Yep.
That was probably 20 kilometers away, something like that.
Yeah.
So
But
is the problem that you have to use a phone for that?
yeah, for any, if you're using RTK to go, you're getting that information over the internet. So
Yeah.
your robot has to have an internet connection.
Right.
Yeah. Yeah, that's why I wanted to do this. Anyway, this is a QTPi on one of the C breakout boards. That's the, what is it? M8P, the Neo M8P-2. And then this is the radio. So that's, and I'm actually only using one battery. This one's kind of taped in there, so I didn't want to take it out. But so that's the base station, and you know, you just need another radio on the rover to receive the RTCM3 correction statements, and if everything goes right, it should work.
Great.
So that's all I had. I was just trying to get the bumper things squared away.
I haven't even considered putting a bumper on it yet. Not till I can find a cone 300 feet away will I put a bumper on it.
Say that
Otherwise,
again.
I'm just wasting my time.
What?
If I put a bumper on it right now,
Oh,
I have
Yeah.
to be able to find a cone far enough away before I have to even consider building a bumper.
oh, yeah. I don't know, the Texas thicket. If you get in it, it's pretty tough.
We don't have much Texas thicket up in Ontario.
Yeah.
Anyway, I actually started out with a longer one and found out that the shorter one actually works better. So I shortened it by like 3 centimeters or so. And so the shorter one, the travel is better. This one actually catches the bolts on the wheels. And so I'm not up to the Ackley rule of 3 yet. Hopefully I won't be, because I've already, you know, I'm printing the second one of these now. So, but anyway, that's all I had.
Well, thanks for the update, Ray.
Sure.
Next up, I believe we got Doug.
Well, I don't have much. I just wanted to show, you know, I'm up to 2 on this board. So, but it was really interesting learning experience to figure out how all the crap that I'd done wrong. Basically, I had some pins on my footprint wrong. And so, you know, essentially when they were made the board, you know, some of them I could correct by just putting them on the backside, but there were a few that were just really screwed up. I don't know. I must have been drinking that day or something, but it was really bad. So went in and fixed a lot of little problems on this board. And, you know, I'm starting to populate it now. This is the power supplies right here. And I've got a board mounted XT60 socket. So the battery will feed into here, and then it goes off to these two regulators. There's a regulator here. I don't know why it's out of focus so bad. 3.3 and then a 5 volt regulator. So I'm pretty excited. I think this one's right. I haven't found a mistake yet. So thinking that this is it. So
is that a 2-layer board?
yeah, I just did 2 layers. I put a ground plane on the back and a 3.3 volt plane on the front. The 5 volt is used minimally on this. It is used, but it's not a plane. And we'll see. You know, like I say, it looks right. So I'm excited about it. And now I want to do another one for another part of the robot. So what I'm trying to do is minimize all the wiring that I can. I want to keep the wiring down to a minimum. You know, I don't want to have a forest of DuPont cables. And that's what I'm trying to do with these boards. We'll see how it goes. So far, so good. Pretty excited. That's all I had to show. I have decided to go away from the Oak-D Lite. Not that I'm changing anything, but I'm going to a Pi Insight, which is a little cheaper than an Oak-D Lite, because it's essentially an Oak-D Lite without the depth. Okay, because I wasn't going to use the depth map anyway, so I just decided I'll just use this. It's called a Pi Insight. That's by Articam, but it uses the same software as the Oak-D Lite. And I've been working on changing the model for my cone detection. I'm using right now pretty much the default that comes off of RoboFlow, which is a mobile net. You know, I'm sure you're all familiar with that model. I want to turn it over to a YoLo 5. So I'm working on that right now. Not that I think it'll buy me anything per se, but, and I know I should probably just say it's done because it works and move on to the next thing, but I want to get it to a YoLo 5 because I think it's possible it might pick it up a little better. So we'll see how that goes. So those are the things I've been working on this week. Yeah, pretty good. So that's it. So robot. That's the things. Trying to get ready for Robocolumbus. So, yep.
Okay, next up we have Tom.
You know, as I attend these meetings, I keep adding more and more things to the to-do list I have to do to get my robot ready. However, here's one that is complete. I'm going to share my screen here. Here, let's find the right one. Go there. And let's get rid of that. I assume you can see my mouse moving.
Mm-hmm.
Yes. Okay. And you can see what I'm displaying. One of the things I had elected to add to this robot I'm building, which you can see in the picture on the left, was some basic non-high resolution encoding, wheel encoding. So that's mounted on this back wheel here. This is the 2 rear wheels are driven by a common motor, and the front wheels are standard Ackerman-like steering, operated by a servo, a radio-controlled servo that I put in to replace the original bang bang stuff that was in there. And that's all working really well. I had mentioned a few weeks ago that I was rebuilding the interface between the radio control servo receiver and the ESP32 to turn it into a serial interface, and that is working really, really well. I don't know if I've talked about that any further here or not, but I'm really happy with it. It's running great. A software UART at 57.6 kbaud, running on an AT-Tiny 85. Really, really nice. That little AT-Tiny 5 is sitting right here on the board. Just a quick overview, the ESP32 and some interface stuff is sitting here. There's a digital display and some push buttons and some more level conversion and an H-bridge sitting back on this perf board. The radio control receiver is sitting here, this black antenna. And right beside it is the GPS, which is mounted but not configured yet on the ESP32. This black box, this black cube, is simply a piece of 2x2 with a hole in it, which will hold the aluminum mast, which will hold my compass. It's about a 2.5 foot long mast. It doesn't fit in the picture, so it's not showing here. Now, the thing that this is about is right here in this corner, there's a little interface board, and right there, there's a bolt, and the bolt goes down through the mounting deck so that it can hold a Hall effect sensor inside the hub of this wheel. And on that wheel, I have mounted a panel that's got 16 small magnets on it in a circle. This was intended to be a prototype, so I've actually just made it up out of cereal box cardboard and some really good double-sided tape. But so far, it's working really, really well. So I glued it in place, and that's what I'll run with until I have a reason to change it. I had planned to do a 3D printed fitting that would hold everything a little more precisely, but this is doing the job. So I'm happy with it. A few more pictures showing details. On the extreme left over here, this is the bottom side of the mounting deck. This is the bolt that comes down and holds a small circuit board that fits just inside the hub. This is it here in the center picture. And that sticking out from the end of the circuit board is the Hall effect sensor. And you can get a better view of the magnets in their circle here, driven by the wheel, riding on the wheel. A little better picture of it over here, again, showing the sensor and the magnets. That's working pretty well. I've got good clearance. I get good signal. I take the Hall effect signal and I run it through one of these boards, which is just a comparator, a 311 comparator. I actually stole it from a module that originally had an infrared sensor and transmitter on it. It works just great, and it's adjustable, and you can get both the digital output and analog. Pardon? Okay.
Bless
so
you.
You can get both the digital and the analog signals out of here, so it's really easy to set the threshold to an appropriate place. Just a quick forward and then backwards. This is the digital waveform that I get showing on my scope. I'm really, really happy with it. We'll come back and look at this again in a minute. That signal comes into a pin on the ESP32. I have interrupt requests turned on that pin. I'm using both the rising and falling edges, which gives me 32 pulses per wheel revolution, which ain't bad. I mean, it's not, it's not state of the art, but it's usable for my purposes, as it turns out. This is the IRQ handler. Because this is an ESP32 running MicroPython, there are no hard IRQs. This is simply using soft IRQs, and that poses some problems, but I've worked around them well, and I'm quite happy with the results. Just quickly, this is basically all there is in the IRQ. There's a bit of error detection and stuff like that, but basically I'm updating a counter because this is an odometry encoder as well. So I'm picking up counts, which I can either count up or count down based on direction logic that comes from elsewhere, this variable forward, which comes out of the motor control logic. So I know which way I'm telling the motor to go. I've used that on other robots and it works well. The rest of this stuff implements a velocity, a speed measurement based on the elapsed time between successive pulses picked up by the IRQ. On a system with hard IRQs, with really good IRQs, this works really well. It doesn't work well here, and I'll show you in a minute why. But I also have a second method. I use two methods to capture velocity from encoder pulses. The other method is a fixed time counter. It basically says every 1/5 of a second, what's the encoder count at, and the delta of the encoder counts per 1/5 of a second is actually giving me some pretty good speed measurements. They are usable from the point of view of a what I call a mild speed regulator, which is what I'll be using it for.
I think I prefer that way myself.
You mean the fixed time?
Yeah.
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 I've used both, and in a previous robot, I had set it up so that depending upon how fast the robot was going, you know, what range it was in, one works better than the other. But in this case, this one doesn't work at all, and it's because of the soft IRQ stuff. It really screws things up when you are attempting to measure precise widths.
Yeah, you don't really care that much about the speed per se. And well, you do if you're modeling.
I do if I'm using a speed regulator.
Well, yeah, but but you don't really care exactly what speed it's going. But what you really care about is that if it's going slower than that, it's going to try harder to go that speed. That's what you really want.
Remember, this started out as a toy, and when I did the initial voltage to speed curve for the motor itself, it's pretty awful. So this will improve it a bit. I discussed this on the weekend on the Vancouver meeting with Bob Cook. He had to do the same thing with his outdoor robot. Yeah. And he says, you don't need much, but it'll definitely make a difference when you're going uphill.
Yeah, yeah, that's what I'm saying. You need something that when you start lagging, it will try harder.
Yep.
You know, if you don't, that's what you don't care if it's going 10 or 9, but what you really want is that if it starts to go to 3, it will try harder to go up to 9. You know.
Yeah, you've got it. That's exactly my intent. Like I said, it's a mild speed regulator. That's all I'm after here. Plus a little bit of backup odometry. As I mentioned before, this is the pulse train I'm getting. I'm only showing you the double pulses, the rising and falling edges. Which is what I used. I had done a number of other tests, but this is the one I stuck with. This looks pretty good, but the pulse widths are not repeatable. There's a bit of variation in the pulse width here. Yeah. So one of the nice things about my DSO is that it allows me to extract the full data set to a spreadsheet, so I can analyze this in ways that the math package doesn't support. So I used that to get a better feeling for the variation in the width. This is for the 32 pulse per revolution case. And the variation is huge. This is a, let's see, what do we got here? The vertical scale is in seconds, this vertical scale. So we're counting basically milliseconds, 1, 2, 3, 4. And the horizontal scale is simply the pulse count. So this shows about 42 or 43 pulses. So you can see the pattern repeating from here to here. So at this point, the pattern repeats again, because this pattern is a function mostly of the slightly irregular spacing of the magnets. It's also a function of the variance in the IRQ response time, because it goes into a scheduled task under FreeRTOS. The average width here is about, I keep doing that, wait till this goes back, I can read it. The average width is about 8.7 milliseconds. So you can see this is a fairly substantial variation. And I was a little worried about that because I wasn't sure that this would be useful for velocity measurements. But it turns out it is. So when I run this stuff through some very mild filtering and I take a look at, first of all, the blue line, which is raw velocity counts per second from the more reliable measurement method, it looks pretty good. This basically start at 0 speed, run up to full speed using my handy dandy radio control transmitter, which works so well, slow her down and then speed her up again and slow her down. That's all this test is. You'll recall that I mentioned that I had a method 1 speed measurement that was part of the IRQ, which is intended to measure the elapsed time in microseconds between adjacent interrupts. That's the yellow line, and that's after some filtering. So that's pretty useless, Jimmy. But the red line is method 2, the one Doug mentioned he prefers as well. It basically counts the number of pulses, in this case, 5 times a second. And I'm getting, I think, pretty usable speed measurements. There's a little bit of lag, but the lag is not going to be an issue for what I want to use it for. So I'm pretty happy with the way this has turned out. So that's all it is. It's been worth a little bit of time to invest in this thing. The whole experiment that you had.
Yeah, Tom, you're on a scheduled deadline, so I know you don't want to redo. I was saying this is where you could have probably picked a little bit of accuracy up. I'm not saying what you got is fine. You know what I mean? You
Yep,
don't
yep.
need.
Nah, he's
No, I'm
saying
just
you got to
saying.
start all over.
I'm just saying, this is where your 3D magnet holder would have been.
Yes, I agree with you. It would have been, but you know what? Not now.
Yeah, right now. But I'm just saying is, well, I was thinking about how hard that would be. All you'd have to do is 3D print the magnet holder, and then just double side stick it to the to where you got the one you got now. So it wouldn't be hard, but it's not. The game wouldn't be worth it.
My biggest fear is that the double-sided tape I'm using loses its stickiness and the magnets start falling off.
Oh yeah.
But so far it's been great, so I'm pretty happy with it.
Well, if you had,
Super glue.
well, no, if you had some thin steel plate, cut out a disc of thin steel behind it, that would probably, those magnets wouldn't go anywhere.
So in terms of getting my code running, I'm at the point where I have ported a bunch of what I call the main loop code from my previous robot, which is written in C++, and I'm converting it to Python because I had a lot of stuff running on my previous robot, my 6-scan robot, including things like the subsumption algorithm and some XL decel algorithms and path following and a bunch of other stuff. So I'm porting all that over into Python now and looking at the things that will work as is that need to be changed. For example, I've never used an Ackerman steering type robot. I've only used differential robots. And that means the direction mechanisms associated with steering and with avoidance mechanisms now need to be different. So I'm thinking through what's required to do that, doing just enough research to make sure that I don't, blow it too badly. I will use a bicycle model. It turns out that lots of people build very complicated models for Ackerman steering, but for purposes of first level path following, none of that matters. So path pursuit, as it was called in one paper I looked at, is basically what I've always done with differential steering. It just takes a little longer to steer. So I'll keep doing that. I have to take a look at some avoidance mechanisms, which are different. Should I hit something or have to back away from something? So that logic's a bit different than I've been using. So we'll work on that a bit. Get the GPS running. I've used GPSs, I've used compasses before, but I've never used them for robot navigation. So I'll be looking for any hints anybody has on how that goes as it develops. I've already looked through Anderson's stuff because I've used a lot of his stuff in the past, but I didn't see anything on GPSs or on Ackerman steering. All his stuff seems to be differential or tractor drive. So anyway, I just added one more. I need to add a front bumper at some point.
There you go.
That's great.
Gotta have a bumper.
Yeah, I gotta have a bumper. If nothing
Tom,
else,
I'm not
I
too
really
worried
start
about
playing the phone. I gotta bump into it. Say that again.
I'm not too worried about object detection. My plan is to find the first cone. And ideally, there's supposed to be no trees or obstacles in the path of the first cone.
Exactly. Or the second or the third, maybe. You and I get to pick where they go, Pat.
Well, when I tried to run it before, I had Doug pick the course. I presented the location I was going to pick it. I showed it to him on Google Maps.
Yeah.
And he returned the cone positions for me.
Okay. Now, just for the heck of it, I got to show you one more thing here. Let's share again, because you'll get a kick out of this. This one. Remember, we saw a picture in the previous presentation indicating a structure that was mounted on a big, thick pylon sticking out of the water. You see that picture? This is from the CBC News last week. The structure underneath, that is this stuff down here, that's the oldest apartment building in the city of Toronto. It's fairly large. It's 4 stories high. It's 120 years old, and it's a national heritage building. Well, it was bought a few years ago by a big developer, and he was thinking he would, develop it because the land's worth a fortune. It's in downtown Toronto. But it turns out that you can't modify the building at all. So he went off to Europe and he found an architectural design team who said, well, we can design a 10-story addition to your apartment building, which we can balance on this little tiny concrete pillar, which we can embed in the central courtyard of the old apartment building. Now go and ask the city for a zoning variance. So he's asked the city for a zoning variance. It's got all kinds of people upset, but the city says our hands are tied. We have to grant you the zoning variance under new provincial legislation passed by our idiot premier, pardon me. But not only that, he says, I can do the entire construction job and no one will have to move out from the building underneath. You can all stay there. It'll be normal.
As an engineer, I love that way of thinking.
So the citizens group has said in one of the focus meetings that the architect and the developer held, they said, can you show us one of these anywhere in the world? And the architectural designer said, no.
Seems like a bad idea, but
I have seen similar things in other locations where they go to all sorts of extents to build over an existing structure, sometimes starting from the side. And there's some really weird ones in Vancouver too, or like different unusual kinds of initial floor structures for various different reasons. But my big question on this one is how many licks until you get to the center?
And when does it start dripping?
This sounds like how he gets his, how he doesn't have to worry about the old building anymore, because when this thing falls down, there won't be.
How many buildings around it are bigger and taller than 4 stories? I'm thinking, yeah, this will definitely block the view or something of the buildings around. But
yeah, there are a fair amount of condo developments in downtown Toronto, yes.
It is an interesting idea.
Oh, yeah.
I like it. Actually, I like it. And they have, I've seen buildings where they have the center support, so they don't hit the footprint of the planet, but usually it's on a smaller scale.
Seems like it would be a bottleneck getting up and down out of that building.
Well, elevator, that center tube is an elevator. So
yeah, just
I
one,
guess you got to go through the old building to get out, huh?
Yeah.
Yes, I mean, you can think of so many questions, right?
I'd love to see the fire escape design.
Yeah.
You jump out and let them below you. They'll have an air mattress there.
Just give everybody parachutes.
It's like an airplane. There's a chute out the back door. I don't know. I thought it was cool.
What happens when you reach the bottom of the stairwell on the 5th floor?
God knows.
It's a 10-foot leap to the roof. Well, thanks, Tom. That was entertaining.
Yeah. I don't know if anybody's ever seen one, but they can actually make an elevator that it has a pretty good magnet and it runs on a rail. And I forget which, it's like Linz's law or something. The speed, the
faster it goes, the slower it goes.
Yeah. Is, how much current is basically generated in the rail that actually prevents it from moving. So it moves very slowly down, but I don't know if I'd ever want to get on one on the top of a building to ride it down to the bottom.
Well, that brings us to open section, the open part of our meeting. If anyone has anything to present or question or criticize, let her loose.
Nope.
Sounds like it's going to be a quiet night, guys.
I was going to ask about anybody's experience with Ackermann type obstacle avoidance logic, especially if you had code. But it doesn't look to be as hard a problem as I thought after researching it today.
It's very simple if you never back up.
Well, I'll have to back up. That's the whole point.
But yeah, my
No, you don't.
my approach to that was that back up and turn one direction or the other and try again.
Yes, yes.
I mean, isn't it generally just safe to back up along the path you came in by?
That's
There's that.
probably what I would do as long as I stick to really simple path navigation, path planning. So that there are some research papers that do fabulous path planning for Ackerman type steering, but I'm not going into that math forest, I'll tell you.
Back
Tom,
up
you
and go. Back
Tom,
up and go forward 10% more speed.
Yeah. Then you might take a look at Bob Cook's run videos,
Okay.
because, you know, he obviously had to turn around at the cones. And I want to say he also had to turn around and he had to fight a tree that was in the way, or if I recall, you know, he had to get around it. So you might want to take a look at those. You might at least give you a hint on how he approached it. And when I saw it, I remember thinking to myself, well, that's nice. But I don't I want to say it's a backup and then turn, but
Yeah, I think that's a good idea, Doug. I just made a note of it. I hadn't thought of that. Does anyone else here use Ackerman steering?
I have in the past.
Gibson used it on one of his platforms, didn't he?
Who?
Scott? Thought he had one that was basically an RC car that.
He was playing around with one, but I don't think he's actually run it in a contest.
Yeah, the last contest he had something that was Ackerman
Yeah,
steering.
YR.
What?
I think it was YR, wasn't it? I don't know. Anyway, yeah, you can also look at Scott and see if he. I know his main robots are differential, but he might
Right.
he might have a
I will mention one more thing here. My wife came home the other day with a present for me. She was out on an errand and she noticed somebody had abandoned one of those kids riding cars and the sign green sign on it. So she brought it home for me.
All right.
So out of it, I got things like a whole pile of 8-inch wheels and these lovely drive systems, gear mode.
Yeah.
So I
Tom,
got,
you're a lucky man if your spouse brought stuff like that into the house.
Yeah.
That's
I know I am, Carl. Thank you. I really appreciate her.
I'm the opposite thing. She wants to throw a bunch of stuff out, you know.
Well, I've managed to reduce the valuable stuff to one large shoebox, and the rest of it will go out in the trash. But
Do
pretty cool.
I will say that we were forced to use Ackerman steering when we decided to remote control the RV.
oh, there you go. Yeah.
But we used the no backup rule.
yeah.
I was intrigued at the number of, I started to do some research on how do people do, path planning and navigation with Ackerman steering for autonomous vehicles. And I was really interested in the number of research papers I found who actually said, we've developed some stuff and we tested it, but one of the rules we applied was we don't go backwards for research purposes.
Uh-huh.
Yeah. Yeah, I actually, those power wheels, I was actually looking at, I've got a set of those and I have an old golf cart, like the type that you pull with your hand. And it had nice big wheels, and I'm trying to make a differential robot, but probably not this year, but it's on I've got all the pieces, and there's two ways to go on for you to think about. You can use the same principle that you did with the magnets. You can open it up and just get into do it to one of the internal gears closer to the motor.
Yeah, the gearboxes are really easy to open.
Yeah, and the other way of doing it, and the way I approached it, and I'm not sure if this is the best way, I'm just the way I approached it. I went out to AliExpress and bought some 550 motors with encoders. They're not as fast. They're not as fast as the ones that they have, but the encoder's all set up. The only thing you have to do is move the pinion gear, so you need to buy one of their RC pinion gear removers so you can pull the pinion off the existing motor and then put it on the other one. And so that's how I was going to approach it, because with those big wheels, even if you're only going kids like to go fast. So if you're going a third of the speed, you're still going pretty fast. Anyway, we'll see how it goes.
What intrigued me is one of the gear motors was actually a steering motor, and this particular toy came with a full radio control as well for parental control.
Whoa.
Yeah, that's not that uncommon, but it also means you didn't get a bottom dollar one.
Correct.
The fact that it has the steering is a motor,
Yes,
that's usually a higher priced model.
Yeah. Well, I was thinking what Doug said, that I might later use this to try and make an outdoor differential drive. I only have 3 wheels out of 4. The reason it was being scrapped was because clearly something really, really heavy had dropped on the rear quarter of this thing. So there's only 3 wheels.
Tom, you'll find that you don't get very good traction with those solid plastic wheels.
I understand.
You probably want to get rid of the thing you want to keep is they call them plums. So hold up one of those motors. If you look at it,
I know what you're talking about. Yeah.
there's a matching piece
Yep.
that goes on the wheel, and you can mount that on almost any wheel. And you can buy those $2 for $6 on Amazon, so they're not expensive.
Yeah.
Or you get
They're out
3D.
here somewhere. It's in the box.
Yeah, there's also models out on Thingiverse on how to print them. And I don't know what your printer's like, but I wouldn't do them in ABS, though. The guy that actually put the model up there did it in ABS, and he said he's been running it for 6 years, so it can be done. You know what I mean? Here in Texas, you leave it out in the backyard, it would be badness. I'm next year, there's definitely going to be a power wheel driven differential. I'm even thinking of making it a 4-wheel, 4 driven wheels. See what we can do. What we can do there.
The reason I packaged it all up in a box is because I have to put it on the shelf, or I'll keep playing with it.
Yes, I agree. I'm doing the same thing, Tom. Not until after the contest. Yeah.
So does the motor shaft stick out on the backside of the motor? Can you stick an encoder on it or something?
That's a good question. I never looked. No, they don't.
What I was wondering is does the back side of the motor, not the side that drives the wheels, but the other side, is there any place you could put a magnetic encoder there? One of those AS 5600 I2C or SPI models.
Yeah, there's nothing. Where's my camera here? There's nothing available sticking out the back end of the motor, and these things are through shaft type mounts. So there's no way that I can see to mount an encoder on the back of the output shaft.
But what you do is you open it up, and there's a series of gears.
Yeah.
And you glue your magnets to one of the gears.
I had the little one open, so I know what you mean.
Yeah, and you use the same thing you did before, a Hall sensor. You're good to go. In fact, you can use 2 Hall sensors if you want to mess and get it quadrature by getting them 90 degrees out of phase.
But the wheels are big enough. I could glue an awful lot of little magnets on the inside surface of the wheel.
Yeah.
So that would have been a good approach, but like I say, I just went with the encoder on the motor. But like I say, you can't get those that you have there. I think something like 20,000 RPMs was the standard motor, and if you buy an upgrade motor, it'll either be 30,000 or 40,000.
Yeah.
So
These motors are also, the whole system's 6 volts, because I also got a really nice sealed lead acid 6-volt battery out of
it
it.
was only 6 volts.
Only 6 volts.
Yeah, well, that's a little chancy. Usually they're 12 volts, and and people upgrade them to 24 volts by just replacing the motors.
I've harvested some of those sealed lead acid batteries, and most of them are trashed because if you don't take really good care of them, they go bad easily.
Yeah, I had this one on my battery tester, but I'm not through yet. So looks good. I've played around with these before a lot, and you can usually tell when they're no good because they rattle. This one doesn't rattle.
Yeah, 75 RPM is at the shaft, output shaft, right?
Yeah. Yeah.
That's
I
nice.
called him up and asked him, I said, can you look at, the backside of the motor and tell me if the shaft sticks out a little? And he said, no, I don't think it does. It's like, no, he wasn't going to go and look.
Everyone I've seen, it's pretty flush. You can't get there.
Yeah, that's what I've seen.
But there's nice places inside the gearbox. I mean, it's pretty roomy. I mean, you could add them there without, just like I said, you just you measure the inside of the gear rim, and you just 3D print a little magnet holder, with spaces for you to stick your magnets in, and put double-sided tape on it.
Now that I'm comfortable with Hall effect sensors, I'm wondering if I can detect the rotation of the magnetic field of the motor as it runs.
You might
There are people who use back EMF to do speed control.
Yeah, that's not what I'm talking about, though.
Well,
I'm talking about a Hall effect sensor to measure the rotation of the magnetic field from outside the motor casing. It's got lots of holes in it.
yeah, okay,
I don't know. I've just an idea.
yeah.
Yeah, the set that I had, the motor shaft did stick out the back, and I 3D printed a 30 slot wheel and had a little opto, interrupter.
Yeah, that would be perfect if I could do that.
Yeah, worked pretty good.
We'll see. Anyway, another project next time.
Oh, so going back to the Ackerman steering,
Yeah.
the first robot I did with Ackerman steering, I ended up setting some waypoints for it, and the turning radius wasn't that great, so it drove past the first waypoint, turned around, came back, and started to loop around until something would nudge it a bit and would get close enough that got close to the waypoint. So I found you have to set a really large radius.
And that's the problem I'm going to have. I've only got plus and minus 15 degrees range on the steering servo before it starts to stall. So I got to think carefully about how I'm going to manage normal navigation if I'm worried about getting close to a target.
Now you can't do something fancy like set up an angle or something for the waypoint, and if you go past the waypoint, then you consider yourself to it, regardless of how close you are.
The research papers I've been looking at that talk about how to do path navigation and path planning for Ackerman type robots, cars basically, is they talk about the fact that you have to pick an appropriate distant path location to plan to in order to be able to make the turn.
Yeah.
And you have to know when you won't be able to make the turn so you can back up while you turn and start over.
Yeah, I want to say that one strategy that I've seen is that you go close where you're hoping that you're close, and then you you essentially turn the steering, and then you kind of loop around into a circle, and then what you're hoping is your camera catches the cone as you turn, and then once you do that, you stop and lock in and go.
Yeah. What I did was, regardless of how close I was to the waypoint, I set the distance to the waypoint, like say 300 feet, right? And so if I went 300 feet, regardless of where I was, I considered myself to that waypoint.
Yeah.
Yeah. Well, I'm hoping that I'll have enough navigation class information available I've got an IMU on it. I've got a digital compass on it. I've got a GPS on it. I've got odometry. Somehow I should be able to figure out where I am.
Yeah, and anyways, as long as you're not getting, sidetracked by going around too many obstacles, then if you go the distance to the waypoint, you're usually there.
As Bob Cook said, he said, your first step is to take it out in the backyard and see if you can keep it from hitting your house.
Yeah.
Yeah.
The first year I ran the test, I managed to hit the garage. So I spotted the traffic cone, turned right towards the traffic cone, kept turning right into the side of the garage.
Yep.
Yeah, that's where I could see benefits of a RAWS type implementation with a full mapping algorithm on it. So you can remember where the garage is.
Yeah.
So is there anything in the rules that state that I can't put a rope between the cone and the target cone and the home cone, and then just have the robot feel along the rope and make its way to the end?
That would be a beacon. It would be
Is that a beacon?
Yeah, it would be a beacon. That'd be one form of a beacon.
Now, what if your robot laid down the rope?
How would it know that to do that?
You can't modify the
Da
course.
Vinci Award.
Yeah. Yeah,
No, I was just thinking if it left a path so it could get back to the starting point.
yeah.
I think breadcrumbs is more picturesque.
Yeah, I like that.
Yeah.
I was thinking lime, just like drop little chalk line as you go down the course. That's actually modifying the course, so that would be illegal.
Okay.
Well, we shall see how it goes. So
Yeah.
don't have a whole lot of time. I need to get some basic functionality running fast and tested.
Wait,
Yeah.
modifying the course is illegal?
Yeah.
Accidentally on purpose drop a few
I
nuts and bolts
mean-
here and there.
I think every robot should have a navigation drone.
I was
Right.
gonna cut a
Take an
few
aerial
ditches
photo.
in the way.
A trench.
So my idea of
Trench,
a lawnmower robot that mows a path to fix the whole grass problem is out.
Yeah. It's real. There's some DPRG clips or run videos, I believe, from pre-COVID. It was if you go in just look up Robocolumbus in the DPRG site, and you find the one where Scott and David and myself ran in. And if you look at that one, you can see that on Scott's and David's robots going to the first cone, they wear a path. They're so incredible. They just the robot just, it leaves a path because it's kind of high grass, and each one goes exactly the same path that it did the time in each run. But another place, if you can find them, they're available. They are out there. Is if you want to look at Robocolumbus videos for Shybots, CHIBOTS, and they, if you just want to see how different people did different things, and they always had a very pretty challenging course.
Is that the Chicago group?
Yes.
Yeah.
I think they went extinct for a while, and because of that, they may not be the easiest thing to find anymore. I don't think their website is active, but if you go out on YouTube, I think you can find them. It's fun because they're totally different. There's guys making Lego robots that do it, and you see guys out there with things that look like, they're monsters. They're like, they make paths robot look like a dink. You know, I mean, I'm talking some bigots, and not necessarily good, but they, you know, they were very, very elaborate. Anyway, there's another source. I've never been able to find SRS's run videos other than Bob's. I think in the past, I don't know if they collected them or not. But you know, there's other. That's a good source of just kind of getting ideas.
Yeah, that's a good point. They're selective on the videos they post. They
Yeah.
only post the videos for their formal presentations of their meetings. They do not include the videos of the discussions.
Yeah, yeah. Let's see. There was one other thing. Oh, Tom, when you guys get there, if you know how last year I went through had a little robot where the robot owner discussed his robot. It's a little mini video about 3 minutes long. You need to do that all, you know, for everybody who's there. So,
Okay.
you know,
I'll leave that up to Pat. He's got the fancy cell phones and stuff.
okay.
You know, there's no Wi-Fi at the field, right, Pat?
Yeah, well, that's so I've got cellular data, so I should have enough cellular data to do the thing. But I'm thinking about bringing something with a larger camera than a phone.
Yeah.
So like I'm thinking of bringing a tablet.
Yeah.
That I can link the tablet to my phone, and then we can get a proper you know, HD size picture, or instead of just a little narrow 16:9 like a phone.
Mm-hmm.
Good idea.
Yeah, you know, you say you have no Wi-Fi. You know what the second biggest problem is? Do you have restrooms?
Yes, we do.
Okay, you're in good shape. The one I was telling you about earlier, that you know, pre-COVID run that we did, they didn't have restrooms. So by the end of the day, it got kind of interesting.
Actually, I should check and see if they're still open at the end of October. They may be locked.
Yeah.
That could be important.
Well, it's not like we're out in the country, right? There's lots of places a block away.
Well, if you were out in the country, it probably wouldn't matter.
All I need is a tree.
My model airplane club ran into that problem. Oh, they're way out in the country, and they got told you gotta have proper facilities, so we have to pay to rent them now.
Yeah.
Always carry emergency toilet paper. That's the key.
Always a roll in the truck.
Okay.
So maybe I'll do that with Tom or Doug or somebody the week before the contest, is to try the video setup to make sure that it will work.
Okay. Yeah. Yeah, because if you're doing a meeting, you kind of probably have to be on a phone. If you have
Exactly. So I'll tether like a tablet to the phone, so we can
Mhm.
have a camera and whatever. But being able to see, I don't know how well we'll see as we're trying to video, and I might have to put a box or something around the tablet to be able to see the picture.
That makes sense. You know, you might talk to Paul, because I know with his RTK, he does some weird, you know, stuff to get all. Otherwise, he uses his phone as his hub or his server, I guess, and everything kind of goes to it. So, might be something that he might have some hints. So, or Carl's usually very useful. Knows about all that stuff. Yeah. Anyway.
Well, tethering a tablet to a phone isn't a problem, and then the phone can, the tablet can use just Wi-Fi like the phone does.
Yeah.
And so I should be able to get in. It's just a matter of starting up a meeting and presenting. I probably get somebody at the other end to start the meeting, and we just be a presenter.
Okay. Yeah,
And
that
then,
might.
Spare batteries.
Well, that's the thing. So I've got, depending what's going on, if I tether it, I've got 10,000 milliamps.
Okay.
So that I can use for charging the phone as we go. And then as long as I got nothing else plugged into the phone. So that was the whole point. being able to use the phone and the tablet to do whatever. I could run both of them off of this the power
Cool.
bank. So
Cool.
So if we're going to use Google Meet to do the recording, we just need to, I guess, do the process check first, because what you see as a participant is not necessarily what gets recorded, right? So
exactly, especially if there's a few people presenting,
yeah,
talking in the background.
yeah, you got to check the transitions. I mean, at least I asked the Google AI today if Meet provided a way that you could monitor what is being recorded, and the Google AI said that it's not possible. Google Meet does not support that, so you get what you get. So we have to experiment and reverse engineer our way into it.
Hey, Carl, what if they're not the person who's the meeting start? So let's say that the meetings actually started in Dallas.
Yeah.
And they joined the meeting. Then if you if the locally you just set the
Doug, I think it's like any of Google's amazing algorithms. They're a black box and nobody really knows how they works. And I would, based on what I've seen in various different Google domains, ads, search, Android development, I would suggest that at the end of the day, you might rely on something and it can change underneath you. You won't be told until you find out the hard way. So I'd suggest that if we want to help make it easier, because it's a complex thing when you got the contest in either Canada or Dallas, I would think we might want to consider maybe dragging out the OBS setup just so that we can be in confident control of actually what's getting recorded.
Yeah.
I would think that's a good suggestion, Carl, that especially if you guys are not at Dallas Makerspace, you're at home, you're on your usual setup.
Either way,
OBS and pins the window and can control what gets put into the video.
Yeah. I don't know where I'll be in town. I think a watch party could be cool in person, but if we do it remotely, either way, I mean, if it's me, I've got this set up with portable monitors, so I can do it anywhere. It's just a matter of how many laptops and monitors to carry. But
okay, well, that would be great. It would help us out at our end.
Let's pencil it in, because you should focus on running robots and having fun, and the most you should have to worry about is getting an eyeball for us on an arm somewhere so we can see what's going on.
Yeah, well, that's the whole point with trying to bring like an iPad or an Android tablet and being able to just shoot a video from that tablet and give you guys a decent screen to see on.
Yeah. If you guys, another option is you could just record the run videos, just record them and don't worry about it. And we watch it the next Tuesday.
We can take, I mean, if you can upload the recorded videos, we can mix them together pretty easily, re-render.
Yeah, well, you could re-render them, or you could play them the day of your competition as well.
Yeah, the one I'm concerned about is I haven't been there, is that if you guys are running and trying to get everything organized and all that, you're going to be running around like chicken with your heads chopped off. So worrying about anything complex on recording is going to just make it that much tougher. I mean, we'd like, and if you can join us in a meeting and just join us in the meeting. And if it doesn't work out, don't worry about it, but record your runs. Record your runs and record your robot interviews. If we have those pieces of video, we can all enjoy it by watching it, on a Tuesday, just let it run, and we could have a lot of fun. That might make it easier for you, is what I'm thinking. Because
that cuts the internet out, right? Because the internet's always so reliable.
It cuts the internet. Then all I need is lots of storage to store a video. So I don't know what it's going to be, 5
That-
gig an hour or something.
Yeah. That,
Um,
yeah, that could be a problem, but
you know, if it's 5 gig an hour, it's not bad. It's
Yeah.
that's doable for a couple hours of recording.
yeah.
Find a space in Google Drive or some cloud where we can stash it.
Yeah. Well, I mean, on your phone,
Yeah.
you know, I don't know I don't know your phone, you know, if you have an iPhone with, 256 gig of memory in it, then it's probably not a problem. If you have a small phone with, using SD cards, it could be an issue, but you could put a new SD card in it, get yourself some additional space.
Well, I got 256 gig of flash drive, which would work
Yeah.
for storing on.
Yeah. Yeah.
The other option is if somebody has a video recorder, we can record it and then just copy the video over.
Yeah.
So I don't have the video recorder.
Yeah.
But I say I do have a phone. I have a tablet.
Yeah. Well, we usually use just a phone. That's what we've been doing the last couple of years. We get the meeting going and then just record the video. And I think you guys have watched it, when we're talking, do you see it live or do you see it last year? Did you see it live?
Yeah, you guys, I believe it was you, Doug, and Carl walked around with the robots and a phone, and a couple places at the far end, the video was getting a little jerky, but
Yeah.
overall, it was phenomenal. It was really good to watch, and I appreciated anything I could get as far as to be able to watch a live or a semi-live video of the event.
But I think we were also recording while we were doing that.
Yeah, we had our bases covered,
Yeah.
and we lucked out because Steve's got pretty good
Yeah. He's got
umbrella Wi-Fi.
Yeah. So anyway, we'll figure it out.
Yeah, I'm looking forward to it. I'm guaranteed to find the spot where I first set the robot down. And anything is extra after that. If it rolls forward, hey, great. If it finds a traffic cone 300 feet away, hey, great.
Yeah. Well,
Yes.
yeah. I'm
So
there.
I got a question for you, Doug. So the idea is to find a traffic cone. Does it tell you the order? Do the rules state the order you have to find the cone?
No, there is.
Can I just rotate in place and find the home cone and get a point?
No, you can't go to the home cone directly, but if you go to the target cone, you can go back to the home cone if you're happy with 6 points.
I just found a use for that backup function.
And so I'm just trying to say that. So you can't go straight. It says in the rules that you have to first visit the target cone before you can go to another cone.
Okay, well, there goes my point.
I think it's either the target or the challenge, but why would you go to the challenge one? If you're going for 6 points, you can go to the target cone and you can go back home. So that is a strategy. It's legal.
Pat, you're going to use your smaller four-wheeled robot now?
I am using my smaller one because
What's its
I
top
had some
speed?
bugs iron out. And
Yeah.
I
What's
wasn't
its
gonna-
top speed?
Oh, walking speed.
Oh, okay.
3 miles an hour or something.
I've had it typically 30 centimeters per second is what I've been setting my speed to. It's not very fast, a foot per second. So 300 feet, 90 seconds or something to get to the first cone. Does anyone else have something to present tonight or discuss?
That's 9:30.
Well, it's 10:30 here.
Yes.
Okay, well, guys. Well, I guess that's it. Thank you, everybody, for visiting, coming to the meeting, and look forward to next week's meeting.
Thank
Very
you.
cool. Thanks for hosting that.
Yeah, very good.
Really appreciate
Excellent
it.
stuff. Okay, folks. See you next week.